Hi everyone, welcome to video 2 of Unit 2, Motor Skill Classification. In video 1 we looked at one-dimensional classification systems, and now we'll be looking at the two-dimensional classification system that's based on Gentiles Taxonomy of Motor Skills. The PDF handout that is on our Moodle page covers the taxonomy for this section. So this system of classification can be described as being organized according to relationships among the component characteristics of what is actually being classified. So the two dimensions of this taxonomy are the environmental context and the function of the action. And each of these dimensions themselves have two characteristics, so we'll be looking at each of those. And ultimately what you end up with, because there's two dimensions and each dimension has two characteristics, we end up with 16 skill categories that are created by the interaction of these things. Our first dimension is the environmental context, and our two characteristics of the environmental context are regulatory conditions and intertrial variability. Regulatory conditions are referring to the environmental factors that specify the movement characteristics needed to perform a skill. So our basic question is, what are the environmental factors that control the movement characteristics of an action? We can have two outcomes in this case. We can have the regulatory conditions be stationary, in other words, the environmental factors that are controlling the characteristics of a movement or action, I should say, are stationary, or those environmental factors can be moving or in motion. Our second characteristic of the environmental context is intertrial variability. And here we're talking about the regulatory conditions of each successive attempt being either fixed or variable. So our basic question is, do the regulatory conditions change from trial to trial? In other words, do the environmental factors that control movement characteristics of an action change from trial to trial, or with each successive attempt to perform the action? And the two options in this case are fixed, where intertrial variability does not exist, so our regulatory conditions are not changing, or variable, where our intertrial variability is present and those regulatory conditions or environmental factors are changing or variable. So here are some examples from sport and physical activity that describe the regulatory conditions. In the first row, these types of actions would be considered stationary in terms of their regulatory condition within the environmental context. So something like any kind of target shooting or archery, for example, our environmental conditions would stay the same, being the distance from the target, for example, in competition. Hopscotch would also fall into this category because the environmental context for performing the movement doesn't change. The sizes of the squares stay the same, the placement of the squares stays exactly the same. The only thing that's really changing is you. On the other hand, we also have motor skills where the regulatory conditions are in motion. So also using a shooting example, something like skeet shooting, where the environmental factor that's in motion is the actual clay, the clay skeet that one would shoot. And then in something like jump rope, where the individual is moving, but that's not what we're referring to. We are referring to the object in this case, being the jump rope. That is the factor that is controlling the movement characteristics of the action, is the jump rope, and that is in motion. The other characteristic of our environmental context is intertrial variability. So do the regulatory conditions change from trial to trial? Our first row of images, the answer is no. There is no intertrial variability for these two events, the first being throwing a discus and the second being the triple jump. The environmental context is the, let's say, the parameters of the discus ring, the size of the discus, for example. Whereas the running lane for the triple jump, that stays exactly the same every single time. So our intertrial variability would be considered no in this case. Whereas in sports such as tennis and soccer, there's definitely a tremendous amount of intertrial variability because every match is different. Every point is different. Every goal is different. So you do have variability with regard to the difference between successive attempts in these examples. Our second dimension within Gentiles taxonomy is the function of the action, and our two characteristics here are body orientation and object manipulation. Our basic question with regard to the body orientation characteristic is, does the skill require the person to stay in the same location or move from one location to the other? Again, this is in reference to actually performing the motor skill. So we can have two options in this case, one being body stability, where the individual does not change locations while performing the skill, or body transport, where the person would, in fact, be moving their location while performing the skill. And then object manipulation is pretty straightforward. Our basic question is an object manipulated? Either yes or no. Is the individual kicking a ball? Are they catching a ball? Are they handling a racket? Are they handling a bat? There's various types of objects that could be manipulated for various motor skills. With regard to body orientation, our two options are body stability and body transport. So some examples of motor skills where body stability occurs, in other words, the individual is maintaining the same location, are things like golf. When you are performing one shot in golf, obviously you move from position to position depending upon where the ball is, but we're not referring to that part. Playing the piano, the hands are moving, but your actual body location is not changing. Something like a push-up could also fall into this category. And then we also have body transport. Body transport can be either active or passive. By active, we're referring to the change in location is directly the result of the individual. Whereas passive could be something like being on an escalator or an elevator or a bus or a car, where your body is not physically moving, but your actual location is changing due to some other external device in those cases. The second characteristic of function of the action is object manipulation. So it's a very simple yes or no. Our first row of images, when you're walking, you're not really manipulating an object unless you happen to be holding something, for example. But just walking itself, no. Push-ups, there is no object manipulation there. Whereas if you're writing, if you're playing basketball, or maybe you perform a field event in track and field, like the shot put, you would definitely be manipulating an object. So when the two dimensions are combined, we get the 16 subcategories known as Gentiles Taxonomy, and that's what the handout shows you. It's basically 16 squares of all the different combinations of the two characteristics for each of the dimensions. And this taxonomy organizes motor skills on the basis of skill complexity, and each category puts different demands on the performer. So if we go diagonally from square 1A in the upper left-hand corner all the way down to the last square 4D on the lower right-hand corner, that's going from the simplest to the most complex skill. So definitely refer to that handout. I would suggest you actually have it with you as you go through the rest of this lecture, because I will be referring to it and it'll give you a sense for how to read it as well. So here's the breakdown for our least complex movement, the skill that is located in category 1A, or the upper left-hand corner of the handout sheet. From the perspective of our first dimension, environmental context, our regulatory conditions are stationary, meaning the environmental context under which the motor skill is being performed is not changing. And then in terms of intertrial variability, there is none, so it's considered fixed. Our second dimension, function of the action, the first characteristic, body orientation, is stable, meaning that location is not moving from attempt to attempt, and whether or not an object is being manipulated during the motor skill, it would be no for our least complex movement or our simplest movement. And now our most complex movement, which is in category 4D, it's basically everything is the opposite. So our regulatory condition is in motion. Our intertrial variability, that is present, so it's variable. Body orientation, we are moving locations between attempts, and we are manipulating an object. So this would be considered the most complex type of motor skill according to Gentiles Taxonomy. So at first glance, Gentiles Taxonomy seems kind of complicated. So why would we want to use something like that? Well, there are some very practical applications for this classification system. The first is that it can act as a guide for evaluating motor performance capabilities, limitations, as well as deficiencies. It's really important for an exercise program, whether that be for sports performance or health and fitness or for rehab, that an initial evaluation is performed. So you can evaluate someone's initial capabilities using this. Another thing that this can be used for is systematic selecting of progression of functionally appropriate activities. In other words, we can try to increase the individual's performance capabilities if that's needed, or if the issue is some type of deficiency, we can try to overcome that by utilizing the taxonomy. And essentially, the idea is that it is systematic. In other words, the progression is inherently built into the taxonomy. And progression is very important for, again, an exercise program, whether it's sport, health and fitness, or even just for physical activity or physical education, but definitely in rehab, progression is extremely, extremely important. And a third practical use is to chart progress. This is, again, another critical component of a quality exercise program, physical education, or rehab program is charting progress. You need to be able to objectively identify the types of changes that an individual is going through based upon the parameters of your program, for example. So being able to develop an individual profile of competencies for an individual based upon Gentiles taxonomy is a really great way to create objective measures for the person's progress. So now let's look at the application of Gentiles taxonomy. I have a number of examples where we are applying this two-dimensional system. The first thing that we'll be looking at is a sports application. We're looking at an NFL kicker, and the motor skill is a field goal attempt. This would be a type of discrete motor skill. It could also be considered a gross motor skill, and generally it would be considered to be a closed motor skill itself because the movement is directed by the actor himself in this case. Not by some type of external or environmental participant, for example. So our first dimension, the environmental context, in terms of our regulatory condition, it is considered to be stationary because the environmental context under which the motor skill is being performed is dependent upon the ball. So for this field goal attempt, the ball is held in place by the teammate, so the ball's position is stationary, which is why the regulatory condition is stationary. Now, in terms of intertrial variability, now we see that there is variation in this case, because even though the ball is held in position by a teammate before the kicker makes contact with the ball, there can be some variation in terms of where the ball is positioned exactly between successive attempts. Of course, other sources of variability between trials would be the distance from the goal posts that the athlete has to kick the ball, and of course environmental conditions. If it's windy, maybe there's light rain, or maybe there's even some cases snow, that would definitely change maybe the strategy that an athlete would use in order to make a successive field goal. But that falls under our intertrial variability category. Our second dimension, of course, is function of the action. In terms of body orientation, our kicker would be moving because there is a running approach to the football itself, and the leg is moving as well. In terms of object manipulation, yes, because the goal is to kick the football through the goalposts. Now, what I want you to figure out is what category of Gentiles taxonomy this falls into. So at this point in lecture, I want you to pause the video, refer to the handout, and try to figure out what category it falls into based upon our 4 total characteristics. So hopefully you had a chance to look at that handout and you figured out that this type of motor skill would fall into category 2D. If you refer to the handout, you can see that the environmental context is shown in the column on your left-hand side, and then the other columns are divided up into body stability first, and then body transport, and within those 2 things you either have object manipulation or no object manipulation. So because of our stationary regulatory conditions and intertrial variability, but they're also manipulating an object and the body is moving, they would be considered, or this would be considered 2D. Another example from football is an NFL running back catching a pass. In our environmental context dimension, our regulatory condition is in motion because the ball is in flight and the goal is to catch the ball. Our intertrial variability, it definitely would be variable because every pass is different in terms of the trajectory of the ball and the velocity of the throw, plus the fact that the direction of running and the velocity of running is going to be variable because different plays have different running routes, and you also have to take into consideration the action of defensive players as well, and that may modify the route as well. For function of the action dimension, body orientation, of course, is moving because the individual is running to catch the ball, and then object manipulation would be yes because the goal is to catch the ball. So again, I do want you to figure out what category of Gentiles taxonomy this falls into. So at this point, I'd like you to pause the video, refer to the handout, and try to figure out on your own what category this falls into before I explain which one it does fall into. So our NFL running back catching a pass, the category is 4D. It is our most complex type of motor skill, and that has to do with the in-motion regulatory conditions, the presence of intertrial variability, the presence of body transport, and also manipulation of an object. So that would be 4D. Now we can look at the opposite end of the human performance spectrum in a physical therapy type of application. So let's say this is an evaluation of static as well as dynamic standing posture capabilities and limitations in an individual who may have neurologic or perhaps some type of orthopedic condition. So there would be an issue in terms of postural stability. So we can look at a very simple motor skill, standing in a room, but ultimately we would like to progress this individual to be able to walk while simultaneously holding a book. So initially we would do an evaluation of the motor skill according to the 16 categories of the taxonomy. And standing in a room is actually going to be something that's very simple. Our environmental context, well, you're not moving and the floor is staying stationary, so in that case stationary is our regulatory condition. There's no intertrial variability, so that would be fixed, and body orientation is stable because there is no movement from one location to the next and there's no object being manipulated. Whereas we want to progress to being able to walk and hold a book at the same time. So now we have some slight changes in terms of our two dimensions. And ultimately, our question is, how do we progress to this more complex or advanced motor skill? So here's an example of a progression that could be used. The first step would be to mainly confirm that the individual can stand without any type of assistance, which would be category 1A. And then from there, since we ultimately want to be able to walk and hold a book at the same time, we want to see if the individual can stand without any assistance and hold an object simultaneously, which would then put the motor skill in category 1B. Now, assuming that the individual can do these two things without any type of problem, then we can progress to something a little bit more complex, where we would ask the individual to walk without any assistance a specific distance in an uncluttered hallway. So now we are in category 1C, where the regulatory conditions are stationary because the ground isn't moving. That's our environmental context. There's no intertrial variability. In this particular physical therapy application, because we assume it would be the same uncluttered hallway every single time. And there is no object manipulation, but there is some body transport, which we did not have initially for the first two steps. And then, of course, our last progression would be to walk without assistance a specific distance in an uncluttered hallway while holding an object. So essentially, we are performing the skill that we wanted to achieve. However, you can increase the difficulty even further, because what if we change it to a cluttered hallway? What if we added people who are moving into the equation? These things would introduce another level of complexity that could progress the individual to performing the skill in a more realistic setting. Another application is a physical education example. Let's say that this is an evaluation of a student's ball catching capabilities and limitations, and we could use the following sequence of taxonomy categories. So our progression for catching a ball, the first would be to catch a ball thrown from the same distance at the same speed for several trials. That would put us in category 3B. Whereas we can then up the complexity slightly by catching a ball thrown from various distances at the same speed for several trials. So we've changed the distance of the throw. So now we have some intertrial variability. We can further increase the complexity by having the individual catch a ball while they're running along a line parallel to the thrower for several trials. So now the body is in transport. The ball in this case would be thrown at the same speed and distance as it was in the previous progression steps, and the person is running at the same speed for each attempt. So we're controlling some of the other variables because we've now introduced this other source of complexity. And our last progression for catching a ball would be to catch a ball while running along a line parallel to the throw for several trials, which is similar to the previous progression, but now the ball is thrown at the same distance but various heights, and the person again is running at the same speed. So there's many different dimensions under which one could change the various characteristics of each of the dimensions. So for example, if our physical therapy patient can perform our first 2 steps of the progression but not the third one, then the therapist would know that the patient is capable of static posture with and without holding an object, but has limitations when performing dynamic posture skills. Whereas the physical education student in this case, for example, could perform steps 1 and 2 but not 3, then the instructor would know that the student is capable of catching the ball while standing, but the limitation exists when they're trying to catch a ball while running. So then you can develop a systematic plan of activities to help the patient or perhaps the student increase their capabilities in the performance of these skills.